In this movie, we will see how to use linear optimization to solve a production location problem. So the scenario is that we have a firm who can make three different kind of batteries, battery type 1, battery type 2, and battery type 3. And this is the demand projection for each of these type of batteries. We need 200,000 units of battery 1 and so forth. Also, this firm can do production at two different locations. Production of type 1 in Philippines cost us 95 cents. Production of type 1 in Mexico costs us 98 cents and so forth. So the question this firm confronts is how to allocate production of these batteries between its plants to meet its demand constraint. Now on the supply side, we have a couple of constraints as well. Let's say that type 1 and type 2 batteries require the same type of machines, so they can be interchanged with each other. In Philippines, our total capacity of type 1 and type 2 battery packs is 75,000 units. And in Mexico, our capacity of type 1 and type 2 combined is 160,000 units. Now, type 3 is totally different. Type 3, the capacity in Philippines is 75,000 units. And for type 3, the capacity in Mexico is 100,000 units. We also have to factor in the shipping cost. It costs us 18 cents to ship from Philippines any unit, and it costs us 10 cents to ship from Mexico. So we have to develop a linear programming model first, in which we will define our objective function, then we will list our constraints, we'll feed them into our solver algorithm, and then we'll solve for a minimization solution. So one thing to note is that when we are putting these in Excel, the cost of shipping is same across all these units from each country. So we can simply add up our shipping cost to the production cost to get our total cost. So for example, in Mexico, the shipping cost is 10 cents from Mexico. So if we want to look at the cost of battery type 100, it will be 98 cents plus 10 cents, which is $1.08. We can do that for all for all of these columns. For Philippines, we can add 18 cents. For Mexico, we can add 10 cents. So once we have this formulated, we can then define our model in Excel. We can define our parameters. Then we can start putting in what our constraints, etc. are. So in Excel, this is our basic setup. We are specifying our parameters first. So we can list down the three types of batteries we need to make. We need 200,000 of type 1, 100,000 of type 2, and 150,000 of type 3. In the next table, we are listing our production cost for each of these types in each of these countries. So we have a matrix where each column represents our cost in Philippines and Mexico respectively, and each row represents the particular type of battery. Then we can also list our supply constraints. As we said, that type 1 and type 2 can be produced from the same equipment. We have a capacity of 175,000 of the combined type 1 and type 2 in Philippines and 160,000 in Mexico. Then 75,000 for type 3 in Philippines and 100,000 in type 3 from Mexico. And in this last table, we have combined our costs, total cost, which is the sum of our shipping cost, which is this column, this row, with our production costs. So now we can start developing our model. We will make a table. Each row again represents a type of battery, and the column represents the production country of that battery. So we can start by specifying that we'll just produce one unit everywhere. And here we are just adding up our total production in Philippines and our total production in Mexico. And then objective function is the sum product, or it's the product of our production in each type in each country with its respective cumulative cost. So it will essentially be the product of whatever this cell is with our total cost in Philippines, then the product of this with the total cost in Mexico. The sum product function will work over like type arrays. So even if I specify a matrix here and a matrix here, what sum product will do is it'll multiply this with this and then this with this, and so forth, and add them all up. So if you look at our objective function, it is some product of this array of cells, B17 to C19, with the sum product of our total cost. So O4 to P6. And once we have our objective function, we can start defining our constraints. Our first set of constraints are simply our demand constraints. We need to have 200 units, 200K units of type 1, 100K units of type 2, and 150K units of type 3. Then this is our total production so far, because we're producing one of each kind in each country. Then we'll put down our supply or capacity constraints. This will be that the sum of type 1 and type 2, which is B17 and B18 in Philippines, will be less than what we specify constraints here, 175,000. And then our sum of type 1 and type 2 in Mexico will be less than 160,000, and so forth. So when we put in the constraints, we will choose this table, and we have, again, the same format of our supply constraint. So when we choose that array, Excel will match up each cell with its respective constraint. And then finally, we can also specify our breakdown of costs. So our production cost will essentially be just the sum product of our production of each type in each country with the production cost of that type in each country. And then we can also add up our shipping cost, which will be our total production, which will be this row times the shipping cost of each of these countries. So when we do some product, Excel will do this times this, and then this 3 times our 0.1. So now we have our model neatly laid out. We have our objective function, we have our control variables or choice variables, and then we have also listed our constraints. Now we can bring this model into our solver. So we go to the Data tab, then we click on Solver. We will choose our objective function. Solver kind of smartly picks up that our objective function is in B22. If it wasn't, we could have changed that. We will do a min problem, and then we will say by changing what cells, we will specify this range. We are changing our production. And then we start putting in the constraints. What are our constraints? Our constraints are, first, that our total production of each type should be at least as much as our demand projections. So we can select this as our first set of constraints. And then our second set of constraints is that our capacity constraint of each type. So we can choose this array, and this has to be less than or equal to how much we are able to produce from each of these locations. Again, because we have our format of our constraints and our choice variable is the same, we can have our right-hand side as just the limits on production. We click OK. So now we have both our constraints added to the model. We will be using the simplex linear programming algorithm. Everything looks good. We can click on Solve. And then we'll get our answer and sensitivity reports as well. So once we do that, we get our solutions right away. Our model suggests that we should produce 40,000 units of type A in Philippines and 160,000 units of type A in Mexico. We should produce all of the type 2 in Philippines and none in Mexico. And then this is our split for type 3. Our total cost, which includes production and shipping cost, will be $535,000, out of which, because we also created this function, our $474,800 is our production cost, and $60,200 is our shipping cost. We can see this by looking at the answer report. We'll be producing 40,000 units of type 1 in Philippines, and then the remaining 160,000 of type 1 in Mexico. We will produce 100,000 of type 2, essentially everything of type 2 in Philippines and none in Mexico. And then 50,000 of type 3 in Philippines and 100,000 of type 3 in Mexico. In terms of our total production, ignore these because it's somehow picked up Philippines, but these are really our total production of type 1, type 2, and type 3. And we're producing 200,000 of type 1, 100,000 of type 2, and 150,000 of type 3. And these are binding. We've met our constraint. In terms of the supply side constraints, our Philippines total production constraint was, our production is 140,000, but we think the capacity was 175,000. So we have an excess capacity of 35,000, and that means that this is a non-binding constraint. And same is the case with the type 3 battery in Philippines. We saw that we could have produced 75,000 total of type 3 in Philippines. We're only producing 50,000. So 25,000 is our binding constraint. And then we can also look at the sensitivity report, which essentially tells us the shadow price of each of these constraints. So if we relax a constraint by 1 unit, what is the impact of it on our objective function? So together with the answer report and the sensitivity report, we can see what is the optimal production amount of each of these types in the 2 markets or the 2 factories that we have, meeting our total demand for these batteries.